All right, so I'm sure a bunch of you were looking at some of the shapes they were talking about in the couple of previous lessons here, and you were like, "What? What is that? Why? That's not a pentagon. That's not a hexagon." You thought they were all regular shaped and everything's the same. Look kind of like this here. Anything can be, any five-sided shape is a pentagon, any six-sided shape is a hexagon. So those labels don't refer to anything. What we have here is what's referred to as a regular hexagon, meaning that all of the angles and all of the sides are all the same. So when we're dealing with a regular shape, then we're dealing with something that looks like this. But a irregular hexagon could, one, two, three, four, five, six. So kind of straight line right there. That could be an irregular hexagon. So today we're just going to be looking at regular hexagons, and what we're looking at is one interior angle of a regular hexagon. Now, or of a regular polygon. So these are all going to be the same. This is going to be the same as that, which is going to be the same as that, all the way around. Now, you should, at this point, be familiar with our formula for the sum. So this is the sum of interior angles of a polygon, adding them all up. And the formula we had for that is we had 180. Yes, we're definitely going to use 180, but we're not going to start with that. We're going to start off with, we have the number of sides, so S for sides, minus 2, and we're going to multiply that by 180. So that's how we get the sum of all of them, right? And that's breaking this into 1, 2, 3 different triangles. Each triangle is 180, so this would be 6 sides, because it's a hexagon, minus 2, which is 4, being 4 triangles, and 4 times 180. Now, if we're looking at a regular polygon, so what we're going to do, in the case with a regular polygon, we're looking at one side, a single interior angle of a regular polygon. What we're going to do is we're going to go ahead and we're going to put the formula in here, and then we're just going to take it, same formula, but we're going to go ahead and divide it by the number of sides or the number of angles. So in this case, we have 1, 2, 3, 4, 5, 6 angles. So this is going to be 6 minus 2. I want to change the color of that. So 6 minus 2 times 180, and then divided by the number of sides, 6. So we're going to break that up. So 6 minus 2 is 4. So we have, this is going to be 4 times 180 divided by 6. 4 times 180 is 720. So 720 divided by 6. 720 divided by 6 looks like we are at 100. Let's see, that's going to be 120. So in this case, each one of these angles is 120, because if you go all the way around, it's 720 for all of them. And so 120, 120, 120, 120, 120, 120, and we get 720. And this will work for any regular polygon. Again, it has to be a regular polygon, because if we look back at one of those weird shapes we had before, where it's 1, 2, 3, 4, 5, 6, right? Each of these angles is going to be different. That's going to be a different angle from that, and all the way around. So this is the interior angle of a single polygon, the single interior angle of a regular polygon. And our formula for that is right here. It's the sides minus 2 times 180. Again, that gives us how many in the polygon, whether it's regular or not. And then we just divide it by how many sides there are, or how many angles there are, because they're all the same. And that's how we get it.